Hi, my name is Hannele Padre, and we're going to talk about the models we use to predict whether or not a patient will survive given a set of data. So before I begin, this is an overview of a presentation. First, I'll talk about the data visualization through Seaborn. That helped me decide how to split my data between testing and training sets, and also if I needed to do any combined attributes. Then I'll talk about the machine learning models that I use and the performance of my best machine learning model with the test set, and lastly, any final thoughts and challenges. So before jumping right into Seaborn, this is what my data looks like. I imported my data through Pandas data frame, and I actually created a new column called pre-existing conditions. I made a new data frame as well. I didn't want to ruin the original one, so I made a copy and added this column. So say like a patient only has high blood pressure, they only have high blood pressure. If they have two diseases, I'll say what they are, diabetes and anemia. And I made this column so I can make more interesting graphs. For example, like this bar graph. So this bar graph counts per pre-existing condition, the number of patients that are in them. So for example, we see that most of our data actually lands in none. And all is actually smaller than I thought it was going to be. I mean, I guess it makes sense because we can't expect like all the patients to have all the diseases. So I think it's more important to think of these as ratios. So looking at anemia and high blood pressure and diabetes and high blood pressure, the ratio between death events true and false is a lot like there's more death events, sorry, that's what I'm trying to say, versus when we look at anemia and diabetes, there's a much bigger gap. And so using that column, I could make other ways, or there's other ways to visualize it, such as making these row plots. And I have my X and Y axis as creatine phosphokinase and serum creatinine. And I did that because in the research paper, they mentioned that serum creatinine and creatine phosphokinase, I'm just gonna call it CPK for short, are good indicators to predict death events. And I feel like it's still actually a bit hard to see if there's any correlations except for only high blood pressure. This set of data, I could draw lines straight through the orange points for death events equals true. So I thought that was pretty interesting. And then another way to visualize this column, I created this plot for pre-existing conditions over serum creatinine. And we can see that with higher serum creatinine levels, there's generally more death events. And also created this pair plot for all my numerical attributes to see if there were any other correlations to look at. So next I created my histograms to examine the distribution of my data. I decided that the distribution of age is what would be more representative to my population in real life. So I decided to split by age. And this is just a snippet of code of how I did that. These are my bins, my labels. I compared the histogram of age for all my values versus my, versus the histogram of my age category. And I tried to get that similar shape. So then when we compare overall versus stratified versus random, we can see that stratified is much closer, more representative than random. So next, I'm gonna talk about my combined attributes. Gonna be honest, this was pretty hard to figure out if I even needed this. I felt like combining a lot of these just didn't make any sense. But you'll see, in the end, I decided to just take it out anyways. But I want to talk about like how I even use it. So I decided to do two attributes to add. The first one is serum creatinine per CPK, and that's because the research paper said that those were strong features to use. And then I did blood ejection fraction per serum creatinine. I did this because I asked this question, is there a correlation between ejection fraction and serum creatinine and death events? And it came out with a really interesting plot. The death events, orange and blue dots, they kind of cluster. You could almost like separate them with a line. So yeah, I decided to try that and we'll see how that works. So these are the machine learning models that I chose. I chose these because these were the classifying models. We can see, oh yeah, sorry, let me talk about the scores. So I ran this first through without my combined attributes class. So scores without added attributes, and these are the scores that I got. And then I ran it again with my attributes, and those are the scores that I got. So we can generally see that random forest classifier performed the best in either case. And actually, we could also see that without the attributes, all the scores performed a bit better, except for naive Bayes. So after picking random forest, I had to fine tune it, and these are the parameters that I worked on. And this is the performance of random forest after fine tuning using my test set. So first starting with no added attributes without the combined attributes class, I have a score of 0.83, and it's a little bit lower than random forest classifier, but I think like that's kind of expected. I kind of saw somewhere in lecture like that's okay to have a lower value. And then with my combined attributes class, I got this crazy high score of 0.88, which is way larger than 0.83 before the fine tuning. So after this, I pretty much decided to just totally disregard and drop any combined attributes. Yeah, concluded that this one's probably better. And then I also made the ROC curve comparison. I figured I'd do it for both anyways. So we can see in my ROC curve comparison that random forest classifier with fine tuning does perform the best. And next is like logistic regression and linear SVC. When we look at my ROC curve with my combined attributes, random forest also again does really well. But yeah, I would settle on no combined attributes, and I think my fine tuning came out pretty okay. So yeah, that's my project. Final thoughts and challenges. I think the hardest part for me was figure out how to fine tune my model and how to interpret my numbers. I was a bit confused about how or why these numbers were higher than these numbers. This is my first time doing machine learning, so I spent a lot of time reading the sklearn API documentation and also the sources provided by Dr. Wendy Lee. And I think another hardest part was realizing that I didn't need combined attributes. I think I spent most of my time trying to work on combined attributes and also fine-tuning, trying to figure out which parameters I should use. And yeah, overall, I really enjoyed the project, and I hope you enjoyed my presentation. Thank you.